Okay, so here's the video review for questions 14 through 17 on the final exam. Let's take a quick look at these where they're wanting us to, first one here, working with rational expressions. First one, we want to simplify the rational expression. Remember that our strategy for simplifying a rational expression is just to factor the numerator and the denominator and cancel like factors. So the top, of course, already factored. The bottom, we could easily find magic numbers that multiply to -6 and add to -5. That would be x minus 6 and x plus 1. And then what happens there, we get the x plus 1 factors cancel, which leaves us a 1 on the top. When I cancel like factors, they reduce to 1 over 1. And so my final answer then just looks like 1 over x minus 6. So if we put that in, it was 1 over x minus 6, right? Yeah. Oh, that's a different question. What happened? Oh, I'm not sure. Somehow, well, I don't know. I'm not in sync with the. Anyway, that's the right answer for the problem we did. So if we go back, then let's look at the next one. Something like this. Find the product. If we're finding a product. Oh, by the way, one more thing also. So if we wanted to, of course, check this before we input the answer, that's an important part. What would we do? Well, we would just pick a random value that's not it's not a 0 of the top or the bottom. So if we pick like, 2, for example, if I were to plug in 2 initially for the function, we would get, if I evaluated at x equals 2, before we would get 2 plus 1 is 3, divided by 2 squared is 4, minus 10 is -6, minus 6 is -12, we'd get -1/4. If we try afterwards, if we plug in 2, our simplified version, we get 1 over 2 minus 6 is -4, so we also get -1/4. So we checked it, it works. Okay, how about here? Find the product. So we're supposed to write a simplified rational function of the form, p of x over q of x. How do we do this? Same kind of thing, right? When we multiply fractions, we multiply straight across. So let's factor both fractions. So the first fraction, we'll make that the yellow fraction, factors to x minus 1 divided by magic numbers that multiply to -20 and add to 1, multiply to -20, add to 1, would be x plus 5, x minus 4. And because when we multiply fractions, we just multiply straight across, we can just write the product of the numerators on top of the division bar and the product of the denominators on the bottom of the division bar. Well, this one's already factored. We already get x minus 4 over x plus 3. Okay, so what do we get canceling here? Well, the x minus 4's cancel, and so we're left with the answer on the top, we get x minus 1. On the bottom, we end up with x plus 5 times x plus 3. And I don't mind if you leave that in factor form. If you want to expand it out, go ahead, but it's not expected. So let's see if this one matches up with the one on the test. I'm not sure why that other one didn't. Is that it? Oh, what? Oh, I think I know what happened. I think I was off by Yeah, I was. So there's our problem, right, okay. So, what do we got here? Our answer was x minus 1 over x plus 5 times x plus 3. Okay, that was right. Yeah. Okay. There we go. And then while we're at it, on that last one, what was our answer? 1 over x minus 6. Let's just show that that works also. So, there we go. Okay, so the first two are good. Okay, so here's the next one. Find the sum. All right, we're adding fractions. We have to get a common denominator. So let's start off by factoring both fractions. First one's already factored. The second one, I can factor out an x, leaving me with an x minus 6. Okay, we're fine. So then what's going to be the least common denominator of x and x minus 6? We want the smallest product of factors that at minimum includes the factor x. As far as the yellow fraction is concerned, the blue fraction would need it to include the factor x and the factor x minus 6. We have a shared factor here of x, and so our LCD would just end up being x times x minus 6. Another way to think about this, well, maybe it's not another way to think about it, but the language that might make this a little bit easier to understand would be to say, okay, so when we get a common denominator, we just need the same thing on the bottom. Well, in order to get the same thing in the yellow fraction that we have in the blue fraction, in this case, all we would have to do is multiply both the top and the bottom of the fraction by x minus 6. And then look what we get. Then we've got this common denominator. So this is all equal to, if I distribute over here, if I distribute the -2, we end up with negative 2x plus 12, all divided by our common denominator, plus 1 over our common denominator of x times the quantity x minus 6. And of course, when we add fractions, once we get a common denominator, we just add the numerators. So effectively what we get on top is just the sum of all that stuff. So what does that equal? Well, negative 2x plus 12 plus 1 is plus 13 over x times x minus 6. I purposely left the bottom factored just to make sure that there isn't some common factor that can be canceled here. But there is not. There's nothing I can do to the top to factor it so that I end up with an x or an x minus 6. So nothing would cancel there. And so this is my answer. Once again, I don't care if you expand out the bottom in this case. Not a big deal. All right, so let's input that. What did I do here? -2. Okay, so I just typed in the wrong answer. The bottom should have been x times the quantity x minus 6, and I typed in the answer x times the quantity x plus 6. So we did the problem right, I just typed in the wrong thing. Okay, so next. Last one for this video. So what about this? Find the quotient. Okay, so what about this? Now, here we've got a sum of fractions divided by a difference of fractions. And so we talked about this a little bit in class. Remember, what we're doing here is when we divide a bunch of stuff by a bunch of other stuff, we have to use order of operations carefully. So order of operations tells us that we're just simplifying, so it's normal order of operations, top to bottom order of operations. What about the parentheses step? There are no obvious parentheses, but you have to remember that there are implied parentheses around the entire numerator and the entire denominator of a fraction. So, as a general rule then, whenever you're doing a problem like this where you have a complex fraction or sum or difference or product or quotient of fractions in the top of a big fraction divided by some arithmetic involving fractions on the bottom, the way to think about this, to organize your thinking, is you have to simplify the top, meaning turn the numerator into one big fraction, simplify the bottom into one big fraction, and then we will flip and multiply when we get down to the multiply divide stage. So first step is, let's take care of the top and the bottom before we flip and multiply. So what about the top? All right, so the top we'll make yellow. So we end up with 1 plus 9 over x. 1 written as a fraction is just 1 over 1. So as far as the top of our big fraction is concerned, the numerator, what would the common denominator be? Well, it's going to be x. We have the two denominators, 1 and x, and the smallest product of those would be just, that both would divide into is just x. So I could multiply through the 1 over 1, top and bottom, by x. And what's that going to give me? Well, on the top of my fraction, I would then end up with x over x plus 9 over x. So I have a common denominator of x. On the bottom, let's make that our green fraction. Well, that looks like x, which is the same as x over 1 if we write it as a fraction, minus 1/5. Well, the least common denominator of 1 and 5 we know is 5. And so I would have to multiply both the top and the bottom of the first green fraction by 5, which would give me 5x over 5 minus 1 over 5. So we have a common denominator of 5 there. So one more step and we can simplify both the top and the bottom. On the top, as we said, when we have a common denominator and we're taking a sum of fractions with a common denominator, we just add up the numerators divided by our common denominator. So x plus 9 is the numerator and x is the denominator. Down here we get a common denominator of 5, and on the top we get 5x minus 1. So now we're at the stage where we can flip and multiply by the bottom fraction. So this could also be written as the product of the top fraction times the reciprocal of the bottom fraction. So flip and multiply. So we're going to multiply by 5 over 5x minus 1. Well, remember that when we multiply fractions, we just multiply straight across. So our answer ends up looking like 5 times the quantity x plus 9 divided by x times the quantity 5x minus 1. And so if we do distribute the 5, we would just get 5x plus 45 on the top. On the bottom, we would get, if we distribute the x, 5x squared minus x. So really, either one of those would be okay. Let's go ahead and input the fully simplified version here, the expanded version. So I gotta remember this time. 5x plus 45 over 5x squared minus x. Okay, so once again, is that right? Oh, plus 45. I almost did it again. Oh, what did I put it in wrong again? Oh my gosh. 5x, oh, 5x squared on the bottom. Man, I can't remember, my memory's terrible today. There it is. That's what we got. It was right. Okay. That's it for that little section.